So this one's gonna be about gravity, and this one would be a short one, honestly. So let's wrap it up. Now, I had this idea reading about Einstein's general theory of relativity. So basically he says that there is no such thing as a force of gravity. Gravity is not because of a force. What happens is that every mass contracts the space itself, it bends space itself. So the space gets bended, and because of that bend created in space, that is why all of the masses attract each other. It feels as it attracts each other, but what happens is that the space is being constricted, space is being bended itself. Now you can check it out, I won't explain it in detail. So when I read that, I had this idea that wait, what if it's not the space that is being constricted, it's not the space that is being bended, but what if, and this is gonna sound strange, what if everything in the universe, everything, every mass, everything that can exist, everything that can has a mass expands, space remains constant as it is. What happens is, now I want you to forget that fabric of space and shit. I want you to just imagine, okay, there is space, there is nothingness, and there is bodies that exist in that space. So the space is nothing and the space is constant. What is actually happening is that everything in the universe is expanding at the same rate. So because the rate is same, then for example, there is an earth and an apple, or say a spaceship that is just above the earth a little bit. So what happens is that earth is expanding, earth is getting bigger at say some rate q, and the body that is also expanding at the same rate. But because the earth is bigger, it would reach, or you can say, because the earth is bigger, earth will expand and it would seem as if it reaches the apple first. So what actually happens is that it feels from the earth's perspective that the apple has fallen down because earth was the bigger one obviously. So what happened is that I would probably put up on animation, or just you can just imagine it yourself. Everything in the space expands at an equal rate. So if this is a copy, then every moment this copy is getting bigger. I am getting bigger, you are getting bigger, everything is getting bigger at the same rate. So when I drop it, say like this, when I drop it, what happens is that this is getting bigger, the earth is getting bigger, so and I am, and everything that is resting on earth is getting bigger. So because we all are expanding or getting bigger, the space seems to constrict. Am I making sense? The space seems to constrict, or it feels as if the copy is moving down, but the copy is staying there. What happens is that both copy and expand, both copies and the earth and the ground expand to fill up the space in between. Am I making sense? The copy and the earth expand to fill up the space in between. That is what gravity is. And it feels as if the copy or the object has fallen down, which is not the case. So, and everything is governed by this, all of the universe. So gravity is just everything expanding, and everything is expanding at the same rate. So I named it Q, the factor of Q, that is the rate. And we could actually find Q in terms of the big G, gravitational constant. And this is amazing. I thought at the time that it's a really fucking great idea. But happiness was short lived. Then I thought, okay, I explained the gravity, or like why objects move toward each other, but what about rotation? Rotation is a big thing about gravity. We see every object rotating about some other planet or some other sun or some other black hole. So rotation is a big thing in universe. So how do you explain rotation with it? Because if one body is constant, other body is, say, moving in other direction, it is still expanding, right? So they would fill up the space and collide, I can say. So as the body is moving up, it is expanding as well, so they would fill up the space to collide. But what if the velocity is so much that it makes up for that increase in expansion, say, right? So it is expanding and the body is moving in, say, this direction, and they both are expanding, but they are expanding at a rate that this body that is moving moves out of the way faster than these two constrict or envelop the space. And this was a nice idea. I thought I explained it, and I was trying to visualize it, I was trying to imagine it a lot, but I just couldn't imagine it. And this was a problem. Why does rotation happen? So I thought this was a great idea. I thought, yeah, I explained it. Just like in the centrifugal force, just like in the one with centripetal force, our initial example, it's like the body is trying to move away, but the force is pulling it in. So it pulls it in just in case. So the body, the gravity is trying to pull in the body, but the body has a tangential velocity, so it moves out of the way just as fast as it's being pulling in. So it remains in a circular motion or an elliptical motion. But okay, that is explained, right? But in my case, that is not exactly what happens, because say expansion, the body that is say a stationary body that is expanding, that keeps on expanding at the same rate in every direction, and the body is moving in, say, this front direction, so it is expanding as well. Now I was trying to visualize it. It took me a lot of time, so I finally figured it out like this way. Okay, the body that is moving, assume that it is not expanding. What's happening is that it is remaining constant, but this body is expanding at twice the rate. This would exactly be like, for example, say you have a lava. That lava is constantly moving outwards, so it is trying to envelop everything inside. And there is a guy on a horse, for example, just to increase the speed. So there is a guy on a horse, so as the lava is moving outward in every direction in a circular fashion, it is moving outward in every direction, and the rider, the man that is sitting on the horse, he is moving in a perpendicular direction, in a tangential direction, so he is moving in this direction. Instead of moving here, he is moving in this direction, right? So let me just define directions first. Say this is north, this is south, this is west, and this is east, right? So currently the horseman is in the north direction and he is moving westwards, and the lava is moving outward in every direction. But so lava is moving in outward direction or in the north direction here, and the horseman is initially in the north direction and is moving in the west direction. So it would seem from the lava's perspective that the horseman is doing a circular motion, he's moving in a circular fashion. But what would actually happen is, once the horseman reaches the the west direction. So here the horseman is moving in westward direction, but as soon as he reaches at some point here, like horseman is trying, everything is expanding, so horseman is moving in westward direction and he is here, the apparent position is here. So lava is moving in the west direction as well, and the horseman is moving in the west direction as well. So they are actually opposing each other, and apparently he wouldn't move down. So this is where it would stop. So all in all, what I'm trying to say is that my theory predicts that circular motion wouldn't exist. What would happen is that bodies would just make a 90-degree arc around bodies, and circular motion wouldn't exist because of gravity, which is obviously not the case. So yeah, I got proved wrong. This one was actually a short one, but I did wanted to make this video because when I actually thought of this idea, I was blown away. I thought, yeah, this is such a cool idea, and I didn't spend so much time on it, which I am proud of. But yeah, this was a really cool idea. This was really clever idea, but wrong idea. So yeah, keep thinking, keep having fun.